and we're very excited to welcome our next guest, Mr. Srinivas Chendi. He is the senior advisor at the policy and community development, and he deals with policy and community development. And he is the South Asia Liaison Officer at APNIC, and he is also currently on the advisory committee. And he has been a great support from the very start. And he's also been very popular to take really fun and interactive sessions, and he make the technical aspects really simple. So I'm sure everybody is looking forward to that, and I won't take up any more time with the introduction, and I will welcome you, sir.
Thank you, Tavleen. Can you hear me?
Yes, sir.
Okay, that's good. Thanks for inviting me, and really happy to be part of the first virtual Youth IGF India. I've been to the last couple of those, physically organized, and it's great to be engaging with you all and learning from you all as well. I was just watching Olivier's presentation. I really love listening to him. He covers so much in just few minutes, and is so passionate about internet and internet governance. So I was given a task to do an interactive session. Now, usually if this is a physical conference, I play a game, a role model game, and we designed that game to teach you how internet works. It's pretty much, you get engaged with that game. It's like a card game, you get engaged with it, and you play the game. But in this virtual scenario, I tried my best to come up with some sort of interactivity for you, instead of looking at the slides and me speaking to the slides. But I thought, I'll engage you in this process. So myself, I work for APNIC, and Olivier mentioned about APNIC. If you remember his presentation a few minutes ago, he mentioned RARs, and one of the RAR, especially the RAR that manages the Asia Pacific region, is APNIC. So I work for APNIC. I wear many hats at APNIC. My primary role is policy and community development. So I look after the policy development, the internet number policy development for the entire Asia Pacific region. That's when I say internet number policies, that's how internet numbers are distributed, how they are used in the Asia Pacific region. So there's a lot of policies around them for IPv4, for IPv6, and for autonomous system numbers. And I also look after the community development. Like this, I'm engaging with you all here, and I've been part of the advisory committee, providing support to the organizing committee for organizing such events, etc. But my other role is I also manage conferences for APNIC, and part of the conferences is I look after the fellowships for APNIC conferences. Now, you are all fellows, you know what fellowship means and what fellowship is. So if you're ever interested in APNIC fellowship, please visit APNIC website. And if you have any questions regarding APNIC fellowship, you can always write to me. I'll share my email ID end of the presentation. So let me share my slides. If I can, yeah, thank you, Calvin. Can you all see my slides?
Yes, sir.
Yes, okay, thank you. So how does the internet work? This was the topic given to me. I don't know how it works. So I thought, why don't we together, let's build the internet and see how the internet works. So what I did is I did some sort of, to bring in an interactive element into these slides. So why we need internet, first of all? Why do we need internet? We need internet, and we've been using internet, for almost many decades now. If you, as Olivia said, the internet really makes us talk to the machines. Okay, so we need that interaction between the machines and humans, and so we build this internet to communicate with each other. Actually, we communicate with each other, human to human communication, but there's many things involved in that human to human communication, and those are the machines, the machine parts, there, and there's various of them. So we as human beings, we understand and we remember names very well. Okay, we remember everyone's name that we meet, almost, but when it comes to the numbers that Olivia mentioned about IP addresses, we can't remember those. There's so many out there and we can't remember. Even if you look at mobile phone numbers of our friends and our family, how many can you remember? Maybe 5, 6, but not all. Not all. If you open your telephone book in your mobile phone, you probably have, over 20, 30 numbers saved in there, but you can hardly remember only a few of them, right? So we need that interaction between the human and machines here, and that's the beauty of internet. So let's imagine, let's assume these graphics on this slide are countries. Okay, maybe the square is India, the green is China, the triangle there is, Singapore. Okay, or whatever you want to imagine. Okay, so if these are the countries, these blocks are the countries, how do we build internet that people living in these countries can communicate with each other, right? So let's do that with an interactive way of building the internet together. Okay, so I will help you, but you will be building the internet with me. All right. So you have listened to Olivia's talk. He actually set the scene perfectly for me. He covered many, many aspects of it. I'm not sure how much of that material you have grasped in the 30 minutes, but those will be very useful for now for this session. So you go to vworks.app on your mobile phone, or if you have an iPad, Android pad, whatever you have, go to vworks.app. And when you go to that vworks.app, you need to enter a number, and that's the number you need to enter. And be ready to play this interactive game. So I'll give a couple of seconds for you all to go to that website, vworks.app, and then you can. Now I won't be able to see how many of you joined that vworks.app, but I'll give a couple of seconds for you to do that. And thanks, Anshul, for sharing that URL in the chat. Okay, one more second, and it's not too difficult. You just type in vworks.app in your browser or on any device that you have, and that number. Okay, I don't have too long for this presentation, so I was given 30 minutes, and I need to wrap up in 30 minutes. Then maybe I probably will be able to take some questions from you all. So let's start. I'm going to move forward. What do we need to build the internet? Now, this question should be appearing on your device. If you joined vworks.app with that ID number, start typing in. You can enter multiple options, multiple answers. Just type one, send it, and then type second one and send it. Now there is a timer which is going to tick once I start this. All right. And you have about around 60 seconds to enter as many as words that you think of. So I'm going to start now. That question should appear on your screen. And I can see how many responses out of how many are actually in the room engaging with this platform. So I see about 38, 39 is fluctuating, but I already received about 22 responses. That's great. The responses will appear on this screen, on my screen here that I'm sharing with you after the timer is finished. Let's see, what do you think, how this internet, what do we need to build this internet? Four seconds. That is fantastic. Well, I'm just looking at the answers. Connectivity, yes. Router, connecting devices, server, routers, protocols, optical domain. Well, you guys actually know quite a lot. That's I'm very happy, so we will go into some of these because I only have 30 minutes for this talk. I won't be covering every word that's put it on the screen here, but we will cover the key parts of the internet, building internet. So I'll go to the next slide, and we have more interactions later on. But let's see if you have mentioned anything in the previous interaction game that I'm displaying here. So the internet started with satellites, right? We had satellites, the satellite towers in each of those countries, and then they started sharing data with each other. And then the cable networks came, the cables came. The one you're seeing is undersea cable. The continents and countries, if you remember, Olivia showed the graph, the map of the cable networks. Each and every country, each and every continent is actually connected with an undersea cable. And this is a fiber optic cable, undersea fiber optic cable. But we still use those towers, and we still use satellites. Not as a regular internet, we use these satellites and towers, but as sometimes we use them as a backup in case we have a cable cut. And you probably would have experienced in your street, where, or the place where you live, you have this hanging cable on the telephone lines or power poles, and a truck goes by and then it chops the cable out, and then you lose internet, right? And it happens undersea as well. The ships sail from one place to the other, and if they anchored in the ocean and they drag the cable too far, and that snaps the cable. And when that happens, the internet then backhauls into the satellites. Now, you may ask the question, then why don't we just keep using the satellites? Yes, we can use the satellites, but with using satellites, there's high cost, very, very high cost, significant cost in using satellite bandwidth. And also, the bandwidth itself is very small, so it's not that fast, like the data travels on a cable. That's why most of the time we use satellites for backhaul communication. If something goes wrong with the cables, we switch over to satellite to keep that communication happening. Okay, so that's minimum a diagrammatic view of these different countries, connecting with each other, undersea cable and satellite communication. What else do we need for this internet to work? What else we need? Now, you already mentioned, so let me move on. We slowly build the internet. So this is the the undersea cable map. As you can see in this map, and I zoomed in on India, there's lots of cables, undersea cables connecting with each and every continent, with each and every country. They're connected. So if you focus on India, there's cable connections coming into Mumbai, and also Chennai. So they call them cable landing stations. The entry point of the cable to the country, it's called cable landing stations, and you may have heard that term from ISPs. And that's where the interconnection happens. So that's where it's connecting. If you see the one in Mumbai, it's connecting to so many places, United Arab Emirates and, Oman and Yemen, and it's going all the way to Egypt over there, and it's connecting to the African continent. And on this side, it's connecting with Singapore and Indonesia and all these economies, Now, these cables, undersea cables, are not from point to point. That when I say point to point, you may see a cable connecting from Mumbai to, say, Singapore, a direct cable. But from Singapore, it could be a different one connecting Singapore to the other continents. But they all share the data flowing through these cables. What else we require to make the internet work? We need internet service providers. So we have internet service providers in each of the countries who provide internet to the users, right? And who also connect these countries or economies together, because the internet is network of networks. So you have network on this left side in the square side, and you have hexagon side, there's networks, and they all interconnect with each other. Now, I deliberately made some ISPs bigger and some small and some medium, because that's the reality of the market. You have some big ISPs in the market, you have some medium ones, and you have some small ones, local ones, within your state or even within your suburb where you live. And some are very large, big, they cover the entire India, right? Bharti Airtel, if you take Bharti Airtel or Reliance, they are big ISPs. So these big ISPs actually have those undersea cables connecting with different continents. And then they sell that internet data to the smaller ones, to small ISPs, or the medium ones. And then their medium ones sell to the smaller ones. And you may probably connect to the smaller one, or you may connect to a medium one, or a large telco or ISP, right? So we need ISPs, internet service providers, to provide the internet access to us. Then what else do we need? We need users like us. We need users. It could be business users, commercial, or it could be home users. We need users to consume the internet and to use the internet, right? And the users may have, the users usually will have a router. As you can see, the small symbol there. It's a router, and it's a wireless router. It could be a wired router or wireless router. Usually the routers that we have at home, you can connect with a wire as well, or you can wirelessly connect to them as well. And what else do you need? You need mobile devices. These days, everyone have a mobile phone or a mobile device that connects to the internet as well. Now you must be thinking, so there's two ways of connections here, right? One is cable connection, and then one is a Wi-Fi connection, right? You can connect via Wi-Fi, or you can plug in a cable and connect. But there is also a mobile connection as well, right? Mobile connection, does the mobile connection depends on these cables? They don't depend on these cables, because the mobile connections, if you're connecting your mobile phone to, say, Bharti Airtel, you're actually using satellites and towers. If you look at on buildings, you see these big antennas, with pointing in bidirectional antennas, So, and you can carry your mobile phone and you can roam around from city to city, or from your place to other places, and you're still connected, because that connection transfers from one tower to the other seamlessly, that you won't even see that, or sometimes you may have a call drop, or you may have a bit of disconnection, and that's when you can see that, oh, okay, I moved from one place to the other place, and then I got disconnected and reconnected again. So there's mobile technology as well, that you really don't need to use these cables anywhere. You can actually connect straight to the mobile technology and use internet as well. But that's still expensive. That's still expensive compared to connecting to an ISP through a cable. The mobile technology is still expensive. And also the data rates are a bit smaller than and slower probably than the cable as well. So is this the complete picture of how internet works? May not be, right? So let's look at what other things we need. Now, the internet is a big bubble. The internet is network of networks. Many have said, we all know that. What is connected to the internet? Well, when we first started, only the servers were connected to the internet. Servers and dumb terminals were connected to the internet. But over time, as the technology is improved, now you can actually surf internet while you're on a plane. While you're going from one place to the other, you can purchase an internet plan on the flight, and you can connect to your family and friends. You can connect your mobile device. You can currently, if you're driving a car, you can still connect to the internet with the mobile technology, and you can connect with a laptop or any device. So if we take one country here, the square, how do the internet connect in this one country? And this can be replicated across all the countries across the world as well, right? But we just focus on one economy, one country, and see what is there, how is it connected. Now, if anyone recognize any of these symbols, I already said there's mobile phone cards and towers, but there's something else appearing here. It's saying internet backbone. Now, you can put it in the chat if you think what that is. Yeah, nodes. Could be, yeah, nodes is not the word I'm looking at, but some of you actually, yes, routers. That's exactly what. It was right in the middle of my screen when I played that interactive slide. They are routers, and they are the symbols to demonstrate what a router is. If it's not a real router, that's not how a real router looks like, but it's just a symbol to demonstrate what a router is, with arrows pointing on all the directions. That means it's doing its bit of sending data across it, right? And then we have the satellites connected to them, we have towers connected to them, and the devices connected to them with cables as well as with wireless. Okay, let's move on. So now this is the big picture here. You already know. Now I've been talking about this, but what else we need? Is this the complete picture of how internet works? No, it's not. It definitely not is the complete picture of how internet works. What we achieved here is we only connected the three countries here together well, we have a satellite up there connecting to them, and we have an undersea cable connecting, and we have users, we have ISPs. So the infrastructure is there here, right? It's called the infrastructure. All this is infrastructure, and we have users as well, and the users have their own infrastructure to connect to the internet. But this is not the complete picture. So again, go to vvox.app, and if you're already in there, I'll give a couple of seconds. If you're not there, join vvox.app, and I'll start this interactivity slide. Think of protocols. Now, Olivier actually covered some of them. Think of protocols that's required for the internet to work. Now we have the infrastructure in place, but we also need protocols to make it work. Think of it. I'm going to start now. Okay. Like before, you can enter as many words as you want in 60 seconds. There's about 14 responses. There's 39 of them in the room participating. And you have around 30 seconds to go, just over 30 seconds to go. Okay, that's good. There's 41 joined now, that's excellent. And just 8 seconds to go. There were 30 responses received. And we will be looking at those pretty soon. Great. What am I looking at here? IPv4, IPv6, that's excellent. TCP, yep. TCP IP. HTTP is a protocol, yes. Intellectual property. That's not an internet protocol. Regulations, no, I was looking for the most. So I like to open the microphones now. If you want to, I'll leave this slide here, but instead of me speaking, any one of you or whoever typed those words, IPv4, IPv6 or TCP, or any of the words that's related to the internet protocol, HTTP as well, telnet, FTP, yeah. I hope this is allowed. I hope you are allowed to speak. So why don't you enable your microphone and tell me what FTP is and what FTP does. Now I'm sharing my slides, so I can't see unless I open the participants window. Did anyone want to give it a try? Since you type that word, you probably know what it is. So don't be shy. I'm also learning, you know, I don't know everything about internet or internet governance. So I'm learning as well. Don't be shy. You can speak up.
Hello.
Hello.
Yeah, Rohit.
Yeah,
Akash.
yes, sir.
Yeah.
You
Sorry,
want me
Rohit,
to
go
go
ahead.
or? Yeah, sir. So FTP is file transfer protocol. So we use it for sharing different type of files from and we store it in different servers. I actually created one of the FTP protocols when I was working for my project. So that's how I know about it. So this is what we
Excellent.
do
Yes.
is,
Yeah,
yeah,
that's
this is,
correct, Rohit. Go ahead, sorry.
yeah. So these are just allows a user to store different type of files, word files, music files, name it. That is the only work it does, saving files.
Yes, it's a file transfer protocol, you know, which transfers a file from one place to one machine to the other machine. And that's how you download some files from the internet, or if you want to send some files, you send the files, you put it on a server and a machine, and then you send the link to the other party, and then they go to that machine and then they download that. Anyone like to pick a word and talk about it?
So do you want me to go for TCP IP? Because I guess I wrote that.
I like to give to someone else a
Definitely,
chance.
yeah.
But thanks so much.
Please.
I'm trying my best to
So
be interactive, you know, as much as possible. Gautam, yes, go ahead.
Yes. So I wrote down that TCP, it's transmission control protocol that allows networks to connect
Yeah,
to each other,
exactly. That's
and
right.
yeah, and it allows the application and programs to communicate within each other.
Yeah, the TCP IP actually goes together, and it
Yeah.
allows the data to travel from one place to the other place. Yeah.
Hello.
Okay, that's great. Thanks both. And Sharada, you want to go ahead?
Yeah. So I had written the word intellectual property
Yeah.
because there are a lot of concepts that come, like the copyright and the copyleft movement, and also, like content on the internet and regulating content on the internet. So those protocols should also be considered. Patents, trademarks.
Yeah, you are very much right, Sharada, but that one is not an internet protocol. We are talking about internet protocol, but you're very right. And this is the confusion between those who know what internet is and those who don't know what internet is. When you say TCP/IP, and if you omit TCP and you just say IP, and even if you just walk into a lawyer's office, a solicitor's office, and you just in your conversation you just say IP, they actually think it's intellectual property. They think you're talking about intellectual property, right? Maybe you may be talking about intellectual property, but or you may be referring to a spam that you received, and you're referring to an IP address, in that spam mail. But the lawyers and solicitors usually, they think it's intellectual property. So thanks for joining in the conversation. And let's move on. So the data is sent over the internet in discrete packets. When I say discrete packets, for example, you have a big envelope, right? When you send that through the pipe to the cable, it gets chopped, into small packets. And then those small packets travel on the cable in various directions. And at the destination, they all come together and they join. So that's why we said discrete packets. And the packets are sent from source to destination. So for example, I'm talking to you all over the Zoom, and that means my voice packets are sending from my machine, my laptop, to you all. So you can all hear me, right? So I'm the source and you are the destination for me. And every source and destination on the internet must have an IP address. So the way I'm connected to you all is, of course, yes, my laptop is connected to the internet, but is the laptop doing anything? The laptop actually have an IP address in it. Everything that I'm saying, I'm talking to you, is actually going on that IP address. Okay. The laptop is actually processing my voice, into packets and putting on that IP and sending to the destination where you're all. So we call this routing. Okay. This is what is called routing, and you will hear this word routing, everywhere on the internet, when you go. How does the routing works? So now all of a sudden, we saw this picture before, right? This graph, but all of a sudden now you have numbers appearing here, and there's 3 different kind of numbers appeared. Okay, and in the interactivity slide that I just played with you, some of you said IPv6, IPv4. So the blue ones here are IPv4, and the green ones are IPv6. But did anyone say what this is? AS17726. Did anyone mention about in that play? I didn't see that anyone mentioning about any other protocol than IPv4 and IPv6. Now this is autonomous system number, AES numbers. We call it in short AES numbers, autonomous system numbers. What are these autonomous system numbers? If you take traditional way of writing letters to friends, right? Like postcard, you write their address, and towards the end of the address, what do you put? Postcode, right? We all know that we have a postcode. Wherever we live in this world, we have a postcode. If you want to send a traditional postcard or a traditional letter, snail mail, you put the postcode. And every router that is connected on this internet, in the internet, in every country throughout the globe, every router have this autonomous system number. as the word says, autonomous. That means that number belongs to that router. So that's how. So if you look at the devices like the mobile phone, like laptops and cars, they have IP address. They don't have autonomous system numbers. They are identified by an IP address, either IPv4 or IPv6. But when the data goes from the device to the router, then the router will send that data across to the other router along with that AS number to identify where it's coming from, right? So it's like a postcode, so it's coming from this postcode to the other postcode, it's going to the other postcode, okay? Now there's IP version 4 and IP version 6. IP version 4 is dotted decimal notation. It's 8 bits. And when IP version 4 was invented or came into existence a long time back, they didn't expect that, it will run out. And so the calculation that they did is, okay, it will give 4.3 billion possible addresses, individual addresses. And they thought, okay, this is enough for the internet to grow. 4.3 billion in those days, 1986, 1975, 69 is a very big number in those days. But no one expected that the internet grows this much. Everyone connects to internet, and every nation, every person connects to internet, and everyone embraces the internet and e-commerce and business happening on internet. So we run out of them. 4.3 billion possible addresses are just vanished, and we still have few left. As a RIR for Asia Pacific region, APNIC, we are still delegating them, but not in big blocks. Okay, we are delegating them in only a very small quantity, those who need them. This is where the internet governance come. The internet governance of internet numbers come. Now this is where the community comes together, and this is a perfect place at APNIC conference where the internet governance happens. The internet governance that you can see with your own eyes and listen to what people are saying is that they debate, they discuss, how much of this address space should be given to whom, what size it has to be, and how it can be used, who can use it. This happens at the APNIC conference, and then the policy get formed. Everyone agrees to a proposal or disagree sometimes. If they agree, then that becomes a policy. And then we, APNIC, we have to follow that policy when we're delegating the resources. So that's running out. So then the IP inventors came with idea of IPv6. IPv6 is hexadecimal format, and we have about 340 undecillions, billions of billions of billions of numbers now in the internet. But the transition is taking slow because it's not backward compatibility. When I say backward compatibility is the IPv4, you can't run a IPv6 on IPv4 network without some sort of technology, intermediate technology, okay? So that's why it's a bit slow, but it's picking up very much now. You can see if you go to APNIC website or email me later, I can show you the statistics. India is actually leading in IPv6 development currently, with Reliance Jio deploying IPv6 for their mobile phones, mobile network. India is actually in top of the world, with the IPv6. And I believe the Bharti Airtel, Vodafone, and everyone else will follow that, and then everyone will slowly move to IPv6. But will the IPv4 disappears when everyone moves to IPv6? May not be. Maybe the IPv4 version still exists, but not in large quantities or not in many networks. Maybe just few networks may be using it. Because they probably, for example, if you look at small islands like Andaman Nicobar Islands, near India, the population there is only like few hundred, right? For few hundred, IPv4 is enough. The ISP in that whoever is serving that country, they may think that region may think, I don't need to deploy IPv6 because I only have 20 customers and I have 20 IPv4 addresses. But still, they have to deploy IPv6 at least in their infrastructure to access IPv6 only content. All right. In future, we may see IPv6 only content. For example, what tomorrow Google decides, all my YouTube, can only be accessed by IPv6, no IPv4, right? That means it's completely going IPv6. Then we need to have some sort of translation from a person or a machine connecting from IPv4 to IPv6. That translation should still happen. Okay, so there's a lot of translation mechanisms out there. I'm not going to go into those now in this presentation, but maybe later. And also autonomous system.
So sorry to interrupt you, sir. Yeah, we would just, if it's possible, to wrap up in the next 5 minutes, as we're running on a really tight schedule right now.
Yeah, I'm towards the end of it. This
sure.
Yeah, thank you,
sir.
Yeah. Autonomous systems numbers also same. We came up with 2-byte numbers, and there's our 65,536 possible numbers, but we ran out of those as well, and now we are using 4-byte numbers, just like IPv6, because these are only used in the routers, ISPs, but the ISPs are growing as well everywhere. If you take in India, for example, 20 years back, you probably only had VSNL, BSNL, only few ISPs. But if you look at now, you have over 1,000 ISPs in India, and all those 1,000 ISPs require AS numbers. So we are running out of those as well. So you might ask me, where do these IP addresses come from? Well, they come from the IETF. They are the ones who designed this IPv4 or IPv6 IP addresses. And then they ask IANA. IANA is part of ICANN. It's a department in ICANN. They give that authority to IANA to distribute in the world. And IANA gives those delegates to RIRs like us, APNIC. And then APNIC delegates, as per the policies in APNIC region, we delegate them to the ISPs or the local internet registries, and they assign to the end users. So when you connect to the internet, it's just like mobile phone. You buy a mobile phone, you need a mobile number, right? So when you connect to your ISP, the ISP will delegate IP address to your machine, to your router. You won't see it. Mobile phones, you see it. You receive a card, you see the number on it, and you punch that number in your phone to make calls. But whereas IP addresses, you don't see them, but your router, every device that's connected got an IP address. We have 5 RIRs in the world, as Olivia mentioned, and every region have their own policies. Okay, the way they distribute IP addresses have their own policies in every region. Sometimes they overlap with each other, sometimes they don't. So for APNIC region, we have our own policies. In our region, our members, our community may say that, allocate only /22 to each ISP, but in other regions, they say just allocate only /23 for each ISP in IPv4, as an example. What are the protocols out there? And I don't think I have seen this one in your answers as well. There's a broader gateway protocol. This is a protocol used between the routers from one autonomous system to the other autonomous system. And there's variations of this. So if a router is connecting from one country to the other country, in this clouds, here, then it's exterior gateway protocol, broader gateway protocol. And if it's within an ISP network, it's interior protocol. So it's inside, they talk to each other, and then external. Okay. So let's quickly look at some of the protocols, what they do. So the TCP/IP, they transport data like a postcard. You put everything in there and you put it in the mailbox. The HTTP and HTTPS, it's web access. You access websites. And there's RTP, real-time transmission protocol, which you use for streaming. These days we are all watching YouTube, we are all watching Netflix or Amazon Prime, and we are all making calls over the WhatsApp or Skype or Viber, and this is the protocol that's used for those, making those ones. Now, there's one more here, and very important one, but it's a question. Go to the vvox.app quickly. I'll start now, actually, and answer this question for me, please. This is the last interactivity slide. Which one is not a protocol? And this was mentioned in Olivier's presentation, and I saw someone responded in the previous slide that we did. So I'm expecting 100% answer, correct answer here, but let's see. I only allowed 30 seconds and time's up, so the results should be coming soon. I'll close it. Well, it is a bit confusing. I purposely did this to see what sort of response I get, but the correct answer here is domain name system is the correct answer, DNS, and they all starts with DNS or DNSC, DNS, but the correct answer is DNS. But majority of you said domain name control. Oh, wow, we are in internet governance here, The word control, a lot of people don't take it very well when you say control. It's a domain name system, okay? Domain name system. So which one is not a protocol is that ones with the tick. Domain name server is not a protocol. Domain name address is not a protocol. Domain name control definitely is not a protocol. Okay. So domain name system is like a telephone book or a yellow pages. As I said, my first slide was there was a robot and there's a human and a machine, right? Now the humans remember names very well. The machines remember the numbers very well. So the DNS is translation. It translates. If you open a telephone directory, what do you see? You see the name and you see the number corresponding to that name. It's exactly the same in a DNS server, in a DNS machine, that you see everything is mapped. The name, for example, youthigfindia.com or .in is mapped to an IP address. Now, if you want to visit youthigfindia.in, then we humans, we type the name, right? youthigf.in, but the machines need to know the IP address of that server or that web page. So it translates to that IP address, looking in these DNS records, and then finding the IP address. So let's see how that happens. So here is a graph. So let's look at the number wise. Number one, end user is asking for, I want to go to www.example.com, and that was sent to the DNS resolver. Usually DNS resolver is within your network or within your ISP. Almost all the ISPs, they run a DNS server. And it goes to the DNS resolver, and then the DNS resolver doesn't know it, so it sends to the DNS root name server. Now, Olivier mentioned about root name servers, how many we have in the world. And the root name server says, I don't know www.example, but I know .com where it is. So it gives the IP address of .com, and then the question goes to the .com server here. And then the .com says, okay, I know where .example is, but I don't know www. Then it gives the IP address, sends the IP address of that one. And then the question goes to the, here, Amazon route 53 name server. And then the Amazon says, oh yeah, I know, where it is. This is the IP address. And that gets sent to the user. And then the web server with that IP address sends the web page to the user, right? That's how it works. What it's doing here, it's taking the name and attaching the IP number and sending it back, taking the name and attaching the IP number of the machine. Okay, so this is what DNS does. now we sort of completed the building of internet. We connected the countries together with the mobile and wired and wireless technologies. We have protocols, for the communications to happen. Protocols are like languages. I'm speaking in English, you are understanding. But if I switch to my mother tongue Telugu, I don't know, all of you will understand, right? That's the protocol, that's the standard. So everyone understands. And now we have a DNS, we have translation technology here to translate what humans are saying to machines and what machines are saying to humans, that translation. So that's my end of my presentation. And internet is for everyone and everything, okay? Moving into future, I don't think internet will be for everyone, but definitely for everything, because there'll be a lot of IoT deployments going to come in place, and all these IoT devices, those machines will be connecting to the internet, consuming the IP addresses. Now we have IPv6, quite a lot of them, but in few decades time, I'm not sure whether those IPv6 will sustain, or maybe someone will come up with IPv6.7 or IPv6.10. Thank you so much. And please do visit our blog, blog.apnic.net. There's wealth of information on all these things that I just talked about with you guys, and everything else as well. So back to Tavleen, and
Yes.
sorry if I went over the time.
No, sir, it was so interesting that we were glued to the screen every second. We really thank you for explaining the entire infrastructure of the internet to us. And you're right, I'm sure we have a lot of things to look forward to in the future as well. And on a related topic, we would now like to move forward on to the next session, and Brinda will be
Please,
introducing our guests to us.
Thanks for inviting me, and thanks for your participation, everyone. I hope you enjoyed this little interactivity. Thank you.